In this video, we investigate the real-world examples of mechanical advantages and moments of the three various types of levers. First-class levers are where the pivot is between the force acting and the resistive load. Here is an example of a first-class lever. L1 and L2 are shown in the free body diagram to the right. At the start of the cut, the angle was 40 degrees, and we measured the force at this point to be 10 newtons using scales and estimated it. The mechanical advantage was calculated to be 2.5, and the perpendicular force acting on the handle was calculated to be 7.7 newtons. When multiplied by the mechanical advantage, we found the theoretical perpendicular force at L2. This was proven using the law of moments on the left of the screen. We concluded that this type of lever has the greatest variation in mechanical advantage ratios compared to the second and third class. Also, that the force required to cut the cardboard would increase as the cutting surface moved further from the pivot due to the mechanical advantage decreasing. Second class levers are where the resistive load lies between the force and the pivot. An example of such is a wheelbarrow, nutcracker and tailgate of a car. Here's one example of a second class lever. There you go. We measured distances A and B to calculate X, being the minimum force required to lift the lid of the beer bottle. We assumed that the bottle opener had zero mass, and that the force X was acting perpendicular to the bottle opener. From our research, we found a video of a similar experiment showing a bottle being opened using a Newton meter. We assumed that our bottle required a similar force to open. This gave us an average force of 21.5 newtons, which we then used in our calculations. The mechanical advantage was its highest in this experiment, with a ratio of 3, resulting in the least relative force required to complete the action. In a third-class lever, the force effort and the resistive force are on the same side of the pivot, where the effort force is closer to the pivot than the resistive load. Examples of a third-class lever include golf clubs, tweezers, and hammers. Here is an example of a third-class lever. A bottle of hobgoblin was weighed, and alongside the acceleration due to gravity, we found its weight in newtons. Similarly, we measured the length of the forearm and called this A, as shown on the diagram to the right. We then assumed that the tendon was 30 mm from the elbow/fulcrum and called this distance B. Then, these measurements were used to calculate the mechanical advantage and find the minimum overturning force where the tendon meets the bone. This is the most complicated example we've used and therefore demonstrated this in a simplified free body diagram to show a third-class lever. In reality, this system is much more complicated and therefore multiple assumptions were made, such as the far arm having no mass, the arm being perpendicular to the acceleration due to gravity, that there was no movement to the wrist, and that the average distance from the tendon to the fulcrum was 30 mm. We can therefore calculate the third-class levers have the lowest mechanical advantage at the arm, as this is the third-class lever with a mechanical advantage much less than 1. This is due to how close the tendon is to the fulcrum. We can also conclude that the force required to lift the bicep with a bottle is 10 times the force acting at the end of the arm where the bottle is being held.